Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel Foundation tier paper from 2019. This is paper 2 and we're on question 25. And so we're going to cover all the questions, so if you find this helpful, please consider subscribing to our channel. So question 25 is a question in which Sally has used a calculator to work out the value of a number y. And it says her calculator display begins with 8.3. I've got to complete the error interval for y. So if the error interval began 8.3, what it's actually telling us is the calculator began with that, and then it's got a load of digits potentially after. Or in fact, it might actually stop at 8.3. So an example, it could be 8.352 going on forever, or it could just be 8.3, or it could be 8.399, etc., going on forever. And it's saying we don't actually know what the remaining digits were. It's just giving us the first two digits on the calculator. It's just giving us that. So it's asked us to do the error interval for y. And what that means is, and it gives us a little bit of a clue here, it's saying write down the lowest value that y could be, which is here, because what this means is this symbol here means we're writing something which is less than, the number here is less than or equal to the number that's here. So less than or equal to. So what that would mean is what we're going to write here is the lowest value that y could have. Well, the lowest value would actually be if there weren't any further digits after the 8.3. So the lowest value that y could take would be actually 8.3 itself. And this second part is saying that we're looking now for a number which is bigger than y. So it's got to be the maximum value that y could be, but just slightly bigger than. Now, if we consider what y could be, the largest value that y could be would be 8.3 with 9s going on forever. So the way we could say that really is we could say, well, that is less than 8.4 because it never quite reaches 8.4. No matter how many 9s we write, it never reaches 8.4, but it will go as close as we could possibly ever get to 8.4. So if we went on forever to infinity, we could say, well, at that point it might reach 8.4, but since we can never get to infinity, we can never quite get to 8.4. So the number that y can never reach and that y is always less than is 8.4. And we can see we've got 2 marks here. So it would be actually 1 mark for getting this one right and 1 mark for getting this one right. If we now look at question 26, we've got a question in which £360 is shared between 4 people, Abby, Ben, Chloe and Dinesh. And we're given the ratio of the amount that Abby gets to the amount that Ben gets. So that means the ratio of what Abby gets to what Ben gets is equal to 2 to 7. And we're also given information about Chloe and Dinesh, and we're told that they're given 1.5 times the amount that Abby gets. So we could write those as ratios as well. So if we looked at the ratio of Chloe and Abby, well, we could say that since Chloe gets 1.5 for every 1 that Abby gets, that's 1.5 to 1. But we don't really like it like that because we don't want a decimal. Well, that's okay because we can change a ratio by multiplying both sides of the ratio by the same number. So if I times that by 2 and I times that by 2, then that'll give me a ratio of now 3 to 2. And the same is true for Dinesh. We can say, well, Dinesh also gets 1.5 for every 1 that Abby gets. So that's a ratio of 1.5 to 1. And so if we multiply both parts of that ratio, we get 3 to 2 as well. So that's times in both parts, so both sides of the ratio by 2. And now what we need to do is really put all these bits together. So because the number for Abby is the same for them all, so we've got 2, 2, and 2, we can actually combine all these ratios together. So I'm going to call it, and obviously it's written nicely alphabetically, A, B, C, and D. So the ratio A to B to C, A to B to C to D is, if Abby's got 2, we can see that Ben, B for Ben, has got 7. And if Abby's got 2, we can see that Chloe has got 3. And if Abby's got 2 again there, we can see that Dinesh has got 3 as well. So what we've done, our first step there, was to combine all of these into one ratio. And now we've got that, we can attempt to answer the question. So we're sharing the £360 between these people in that ratio. And so when we're sharing a ratio, what we need to do is we need to add all these up together. So 2 plus 7 plus 3 plus 3. So if we do that, we get 9, 12, 15. So the sum of all of that ratio is 15. So we could say we're sharing 360 into 15 parts. And so we can say 15 parts of our ratio is equal to £360. And what we always need to do then is find out what would one part equal. So one part equals the 360 divided by, so I can write that as a fraction, that means divided by 15. So if we work that one out, what we'll get is that that's £24. So we can see that one part in our ratio is worth 24. And we could just do that on the calculator, by the way, because we're on the calculator paper. And so we were looking for the amount of money that Ben gets. So Ben got 7. So we can see there Ben's got 7 parts. So Ben's share, so what Ben gets is 7 parts. And so to do that, that would be 7 times 24. And again, because we're on the calculator paper, we could just do this using a calculator. I'm just going to do this just using long multiplication as column multiplication. So if you want to skip this a little bit, you can, because you could use a calculator. But 7 fours is 28, and so carry the 2, and then 7 twos is 14, plus the 2 is 16, so carry the 1, and we can see that Ben gets £168 of our shared amount of money. Question 27 is a question about standard form. So standard form is a way of writing very big or very small numbers. So in this case, we've got to write this number, which is written in normal form, so ordinary form, how we would normally write it as a decimal, in standard form. So to be in standard form, we've got to have one number in front of a decimal point. So an example of a number in standard form could be 9.3 times by 10 to the 2. And we can see the number here, we've got one number in front of the decimal point. So only one number in front of the decimal. Okay, and then a decimal point, and then sometimes there are decimals, and sometimes it doesn't have to have any numbers after the decimal point. And then what we have is 10 to a power, and that power could be positive or negative. So we could have had a plus there, or we could have had a minus. So that power could be positive or negative, i.e. a minus. So that's what a number in standard form is. So we've got to try and put this one into that form. So the way to do it is take the first number that's not 0, which is the 5, and just put a decimal point after it. And then we would get the 62 after that. We don't need to write any further zeros. And it's going to be times 10 to something. We've got to work out what that something is. And because this is a number which is a small number, i.e. it's a decimal, 0.0 something, it's actually going to be a negative, because that's what happens when we've got a decimal like that. It becomes a negative power on the 10. And we look at how many places the decimal point would have to move. So it's 1, 2, 3. We can imagine it's skipping between the numbers. So it's moved 3 places. And so we write a 3 there. So that's written, this number, which is in ordinary form, is now in standard form. And we often need to go in the opposite direction. So part B, what we've got is a number which is written in standard form. So standard form, again, being that bit where we've got a number and then followed by a decimal point with some other numbers, times by 10 to a power. And we often have to write it in ordinary form. So we have to go back to the form of writing a number which we're used to. So the easy way to do that is to show our working. And so I'm just going to write this number down again. And when it's a positive power there, so that's actually a +3. If it was add a minus in front of it, it'd be a negative power. We take our decimal point and we get it to skip as many places as the number. So we can see we go 1, 2, 3. And so now the decimal point is just after the 2. So that would mean that 1.452 times 10 to the 3 is actually equal to this with the decimal point moved. So it's equal to 1452. We could write the decimal point there, but really we don't even need to do that, because when you write a number normally, say if you have the number 10, you don't call it 10.0. So we could just write for our answer 1452. And that's it. So that was converting, in the first case, from ordinary form to standard form, and in the second case, from standard form to ordinary form. So I hope that's been helpful to you. If it has, as I said before, please consider subscribing to our channel and giving the video a thumbs up. Thanks for watching.